Okay, the first question right here, it says that GH and GI are tangent to the circle, so GI and GH are tangent. One of the theorems we learned is that when you have two tangent lines from the same exterior point, they are the same length, so this is the same length as this. Yes, Hudson?
I can't guesstimate on the test because it's not multiple choice, right? I have to know exactly.
See.
Oh.
It says a circle centered at 0, so that means that this would be a radius, and the radius and the tangent line are perpendicular, so this would be a right angle. Then it says given OH is 3.2, I kind of wrote on the 3.2, but it said 3.2 there. And then it says GI is 6. It wants to know the length of OG right here, this. So find OG. Well, since these two tangent lines are the same length, if this is 6, then this is 6. And then you have a right triangle, and you can use that right triangle to find OG. So we're going to use Pythagorean theorem, a squared plus b squared equals c squared. And then this would be your a and b, 6 squared plus 3.2 squared equals c squared. 6 squared is 36. 3.2 squared is 10.24. And then 36 plus 10.24 is 46.24. And then take the square root of both sides, and c is 6.8. So that is your length of OG. Okay, then we're going to move down to this question here. It says in the figure below, AD and AB are tangent. So AB and AD, this whole thing, but I'm going to highlight this part specifically, and you'll see why in a second, are tangent to this circle. It also says that the circle centered at O, and then DB passes through that center. So with that passing through the center, this would make a 90-degree angle with the tangent line. Then what else did it tell us? It says, given that AD is 29, so this whole thing is 29, DB is 20, so here is 20, find the length of DC. So DC right here is what we're trying to find. What? Okay, so what we're going to do is we're going to use this right triangle to find this length, which this length is the same length as this because two tangents from the same exterior point are the same length. So once we find this length, we'll have this length, and we can subtract that from 29. Do you want to say that again? Okay, so this is the same length as this, and we just subtract that from 20. Okay, so we're going to use Pythagorean theorem. So just like a squared plus 20 squared equals 29 squared. $29 squared is 841. Then square root both sides. And here I have a equals 21. And so that's the length here. And if this is 21, then this is 21, this length. And then to find this missing piece, CD, I just do 29 minus 21, which would be 8. So that is our answer. CD, or DC, is 8. Okay, then the next one. The next one is much simpler than this. The two concepts that you need to know for this problem is that when you have a circle in a central angle, if this arc is 66 degrees, then the central angle is the same degrees. And then the other concept is that if you have a circle and a tangent line that goes like this, and then a chord that cuts the circle like this, if this is 66 degrees, then this angle is half of that, which would be 33 degrees. Okay, so then applying that to this, it says suppose that arc KL is 66 degrees, so say this is 66 degrees, then this angle would be 66 degrees here. the central angle, and then this angle over here, like this little angle, LKM, would be half of 66, which would be 33. So like 66 divided by 2 is 33 degrees. So then it says LKM, that's the smaller one, is 33 degrees, and KJL is 66.
Does it get easier after this lesson?
I don't know. I guess it depends on you. I've been doing all your ALEKs. Probably. Anyways, okay, over here for this one, definitely label the shape. I know it's on a computer, but I would draw it out on a piece of paper, then label it so you can see what's going on. It says arc AB is 50 degrees, and then CD right here is 74 degrees. And then it says find the measure of CED, right here. Okay, so the average of these two arcs is going to be this angle measure. So we can add 50 plus 74 divided by 2 equals the angle. So 50 plus 174 is 124. Divided by 2 is 62 degrees. 62 degrees here. Yes.
After you're walking out in that.
Yeah. And it's loud because of the, like, metal. Anyways. Okay. Hopefully it'll stop. Okay. In the figure below, PUR is 64 degrees. So again, just label it so you can see it visually. And then it says that ST is 44 degrees. So this is 44 degrees. And then arc PR right here is what we're trying to solve. So this is X. And the equation for this one is big arc minus small arc divided by 2 equals measure of the angle. I hope it's not ruining my recording. Like background noise.
I'm not gonna hear you.
It's like aesthetic math vlog. ASMR. Anyway. Okay, so big arc is X. Put it minus small arc 44 divided by 2 equals measure of the angle, which is 64. And then from here we solve for X, so multiply this by 2, multiply this by 2. Let's keep it this. X minus 44 equals 128 plus 44. X equals 172 degrees. And of course, make sure it's logical. It shouldn't be bigger than 360 because 360 would be all the way around the circle. It should be bigger than the small arc, of course. And just, yeah. Okay, next we are going to move over here to this one. The equation for this one is this exterior segment right here. It'll be EG squared equals CE times, like, the length of this whole segment, DE. Okay. Then, looking at what they gave us, I'm going to label this segment. So ED is 31.5. And EG is 21. And then it says find CD. So I'll use a different color. Oh, maybe this one. Okay. So we're finding CD, so this is X. Okay. But for the equation, we actually need CE right here. So CE would be 31.5 minus X. Okay. Then we plug the numbers in the equation. It'll be 21 squared equals CE is 31.5 minus X. And then we got 31.5. Oh, it says 31.5. And then we solve. So 21 squared is 441. To solve this, you can distribute these to both sides, or you could divide both sides by 31.5 at first. I guess it's up to you. 992.25 minus 31.5x. Subtract 992.25. We get negative 551.25 equals negative 31.5x. Divide by 31.5, divide by 31.5. X equals 17.5. So the length of CD is 17.5. Okay, the next one, it is like the way the theorem states, it's this exterior segment times the entire length of this segment equals this exterior segment times the length of the whole thing. So labeling the segments, UX is 22.5, UY the whole length is 60, UZ is 30, and then UW is what we're trying to find. So then 60 times 22.5 equals 30 times x. I guess we should have put 22.5 first. I don't know. Anyways. Here, I'm going to rewrite this just to be... It equals the same thing, but I should have done it in this order. Okay. So the short exterior segment times the whole thing equals the short exterior segment times the whole thing. And then multiply these two numbers and we get 1350 equals 30x. Divide by 30, divide by 30, and x equals 45. So UW equals 45. And of course, make sure it makes sense. It should be longer than the short part, of course. Okay, now what's left is just the equation of a circle questions, which I know you guys prefer. Okay, ready? Yes, Tar. Oh, go ahead. Okay, so for this one, we're going to use equation of a circle, which just write it down, x minus h squared plus y minus k squared equals r squared. And then hk is the center of the circle. And remember, the subtraction symbol is part of the equation, not part of those numbers. Okay, so then from here, it asks for the radius in the center, so just pull it out of the equation. The center is going to be positive 1, positive 2. We're just taking those numbers out. And then the radius is the square root of 16, which equals 4. So 4 and 1, 2. And then once you have the numbers, you can graph it. So 1, 2. And from the center, I'm just counting out 4 units in each direction so I can draw the circle. This part will be easier on the computer because, yeah, it'll be more perfect. Okay, and then the next one, we're writing the equation of a circle, gives us a center, so that would be h and k. And then we need radius. It only gave us diameter, so just divide this by 2 to get the radius of 5. And then we can plug these values into the equation. So it would be x minus 2 squared plus y minus the y value squared equals radius squared. We don't leave this as 5 squared though, we're going to leave it as 25, so it'll look more like this. Y minus 6 squared equals 25, and then this would be your answer. Okay, the next one, we have the center of the circle right here. We need the radius to make the equation of a circle, and the only way to find a radius would be to find the distance between these 2 points. So it's giving you the center and then a point on the circle, and then the distance between those 2 points would be the radius. So the radius is the distance, and so we're going to use distance formula, which is on the reference sheet. It is x2 minus x1 squared plus y2 minus y1 squared. Label the points x1, y1, x2, y2, and then plug the numbers into the equation. Okay, add the opposite, we get 4 squared, 5 squared, 16 plus 25 is 41, and so square root of 41 is the radius. And now that we have the center and we have the radius, we can plug these into the equation of a circle. So it'd be x minus negative 5 squared plus y minus 1 squared equals square root of 41 squared. The thing is, we don't leave this as a double negative, we put plus instead, and then square root of 41 squared is just 41. So our final answer is x plus 5 squared plus y minus 1 squared equals 41. Okay, the last one is the one with the most steps. You definitely need to practice this if you haven't. It gives you the general form. You have to change it into standard form so that way you can pull the center and radius out and then graph it. Also a very common test question. So the process is group your x's with your x's. So we have x squared minus 6x plus blank. And then your y's with your y's, y squared minus 2y plus blank. And then this negative 15, we just put it on the other side of the equation. We get positive 15 over here. Okay, and then from here, we take this term, put it over here. You take this middle term, divide by 2, and then square it to get positive 9. This number goes right here. And then whatever you add on this side of the equation, you also have to add over here. Then this number, do the same thing. Divide by 2, square it to get positive 1, add it to the other side. Then we're going to factor this. Two numbers that multiply to 9 and add to negative 6 would be negative 3 and negative 3. Factor this one as well. Two numbers that multiply to 1 and add to negative 2. Alex, you're ruining my vlog. I'm trying to be YouTube famous. My retirement plan. Okay. Stop talking about me. Anyways, okay, then simplify this. X minus 3 squared plus y minus 1 squared equals 25. So that's standard form. We don't really need, well, it doesn't ask for standard form, but we needed it to find the center and the radius. So the center is now positive 3, 1. The radius, take the square root of 25. Radius is 5, center is 3, 1. And then once you have the center graphed, you just kind of count 5 in each direction. 1, 2, 3, 4, 5. Okay. And then we're done. Okay, and your to-do list is, where's my to-do list? Oh, there it is. Okay, so leave this out so I can give you credit for it. Complete chapter 10B practice test on ALEKs. Remember, if you get any variations of these problems, put them on the back so you have them for the test tomorrow.
Oh. And then I will leave my arm to leave this so my arm for the whole. Now, we're going to do that.